In experiment number 5, we're going to be looking at rates of reaction. And in particular, we'll be demonstrating the effect of concentration of reactants on that reaction rate. And at the end of the experiment, you'll have enough data that you'll be able to process it and find the order of reaction with respect to one of the reactants. For this experiment's PreLab assignment, you'll need to look up the safety data sheets for dilute potassium iodate and sulfuric acid solutions. When you get to the lab, we'll discuss the answers to the PreLab safety questions and answer any questions you might have. Now, the first data table for this experiment might look complicated, but it isn't so bad. For the PreLab assignment, you'll be filling out most of it before you even get to the lab anyway. The last 3 columns are just for concentration and then various manipulations of the concentration. So the goal of our experiment is to find the order of reaction with respect to iodate. So the last 3 columns are all going to be based on iodate concentration. Within a row, say for trial A, you can find the concentration of iodate because you're going to know the initial volume of iodate solution and the initial concentration of iodate solution. So those are 5 milliliters and 0.02 molar respectively. And then you also know the final volume, because the final volume is just the combined volume of iodate solution, water, sulfite solution, and water. So 5 plus 45 plus 10 plus 40 gives you 100 milliliters for your total volume. And that 100 milliliters is going to be the final volume in all of the different trials. So once you have the concentration of iodate, you just take the ln of that concentration for the next column, and then you just invert the concentration for the final column.
Because the actual procedural steps that you'll be taking are going to be the same for all of the trials, we're only going to give specific directions for trial A.
To start, you're going to need to obtain a graduated cylinder and then add 5 milliliters of 0.02 molar iodate solution. And then to the same graduated cylinder, you're going to add 45 milliliters of distilled water, bringing the total volume in that cylinder to 50 milliliters. Then you need to obtain a second graduated cylinder. And to that, you're going to add 10 milliliters of 0.02 molar sulfite solution. And then to that same cylinder, you're going to add 40 milliliters of distilled water, again bringing the volume up to the 50 milliliter mark. You now need to mix the solutions in these graduated cylinders in order to start the reaction. The way to mix the solutions is to obtain a 250 milliliter Erlenmeyer flask, and then pour the contents of one of the graduated cylinders into that flask. And once you've done this, you can then pour the contents of the second graduated cylinder into the Erlenmeyer flask. As soon as you've mixed the contents of both cylinders into the flask, you need to start swirling and start timing. And then keep swirling until you see a sudden and dramatic color change. And the instant you see that color change, you should stop timing. Then record the time in the data table. And now you've got the first data point for each of the 3 graphs that you need to make. Then you're going to thoroughly clean your glassware and move on to the next trial. And then you repeat this process until all the trials are finished. And then once you've done trials A through E, you'll have all the data you need to make your 3 graphs. And you can then move on to the second data table and the iodate solution with the unknown concentration. So you're going to perform the same type of experiment as before, but using the volumes from the second data table and using the unknown sample of iodate instead of the one that you've been using previously. Once you've finished the unknown trial, record the time it took for the reaction to occur in the data table. And at this point, you'll have finished the experimental procedure and you can clean up all your glassware.